Hello everyone. Today we are going to discuss about principles of experimentation and design. Introduction. Experimentation and design in mathematics are crucial for exploring concepts and developing new ideas. Experimentation involves formulating hypotheses, conducting experiments, and analyzing results. Design refers to the intentional planning and organization of mathematical investigation. Purpose of experimentation. Experimentation in mathematics helps to test conjectures and validate mathematical theories. It allows mathematicians to explore patterns, relationships, and structures. Through experimentation, mathematicians can make predictions and develop mathematical models. Principles of experimentation clearly define the research question or problem to be investigated, develop a hypothesis or conjecture based on existing knowledge and observations, design experiments that allow for controlled and systematic data collection, collect relevant and reliable data using appropriate measurement tools and techniques, analyze the interrupt the data to draw meaningful conclusions, communicate the findings and implications of the experiment effectively. Importance of design. Designing mathematical investigation helps to ensure accuracy and reliability of results. It allows for controlled testing of hypotheses and variables. Good designing minimizes bias, confounding factors, and errors in data collection and analysis. Principles of design clearly identify the variable and parameters involved in the investigation. Plan and implement a suitable experimental procedure or methodology. Consider ethical consideration and potential structures of error in the design. Use appropriate sampling techniques to ensure representative data. Control extraneous variables and apply randomization where necessary. Determine the sample size required for statistical significance. Data collection and analysis. Use mathematical tools and software for data collection and analysis. Apply statistical techniques and mathematical models to analyze the data. Interrupt the results in the context of the research question or problem. Types of experimentation. Experimental studies involve manipulating variables and observing the effects. Observational studies involve collecting data without manipulating variables. Simulation studies involve creating models to mimic real-world scenarios. Experimental design, randomized controlled trials. Randomized controlled trials are commonly used in mathematical educational research. RCTs involve randomly assigning participants to treatment and control groups. The design allows for comparing the effects of different interventions or instructional methods. Experimental design, quasi experiment. Quasi experiments are conducted when random assignment is not possible or ethical. They involve comparing groups that naturally differ in some key aspects. Quasi experiments have less internal validity but can still provide valuable insights. Experimental design. Correlational studies. Correlational studies explore relationships between variables without manipulating them. They provide information on the strength or direction of relationships. Correlation does not imply caution but can guide further experimental research. Designing mathematical models. Mathematical models are used to represent real-world phenomena and solve problems. Designing mathematical models involve identifying relevant variables and relationships. The model must be tested, refined, and validated using experimental data. Continuation. Mathematical models can be expressed using equations, graphs, or computer simulations. Designing models requires simplifying assumptions and considering limitations. Models should be able to make accurate predictions and provide insights into the problem. Ethical considerations. Experimentation in mathematics should adhere to ethical guidelines, obtain informed consent from participants, and ensure privacy and confidentiality. Minimize harm and ensure the benefits outweigh the risk. Reporting and communication. Document the experimental design, procedures, and data collection methods. Clearly present the findings, including statistical analysis and interpretations. Communicate the limitations, implications, and potential future directions of the research. Conclusion. Experimentation and design in mathematics are essential for advancing mathematical knowledge. Following principles of experimentation and design ensures accurate and reliable results. Effective communication and collaboration are crucial for sharing and building upon findings. Thank you.